All right, so we've got moist air entering a humidification device, but we've also got a heating process going on. And we want to find the mass flow rate of the water being injected in pound mass per minute. And then we also want to find the rate of heat being added. So this is a combination of heating and humidification. So to find m.w, we need to do a mass balance. So I've drawn my control volume here. You see it with the dotted line. And for my air, it doesn't change. It's one inlet, one outlet. m.a1 equals m.a2 is equal to just m.a. For my water, I've got, well, let's see, I've got two inlets and one outlet, right? I've got water coming in with the moist air at state 1, and then I've got water being injected, which I've shown with a blue arrow there. So m.v1 plus m dot of the water is equal to m.v2, and you can arrange that to get things in terms of just m.a. And we've walked through that example in class before of how we get that into terms of m.a. And I'm going to say, well, let's see. Oh, yeah, m.a2. The reason that I'm focusing on m.a2 is because I have the volumetric flow rate of the atmospheric air at state 2. So I know that the m dot of the dry air can be defined as in terms of the volumetric flow rate of the dry air at 2 divided by the specific volume of the dry air at state 2. And then by Dalton's model, I can say that the volumetric flow rate, the volume and the volumetric flow rate of the components are equal to that of the mixture. So there's my governing equation for m.w. And since I'm at 1 atm, I'm going to go ahead and go into my psychrometric charts here and pull off some of the values. So there I am at state 1. And then at state 2, I'm given two properties to figure out where I am. So I've got my dry bulb temperature, and then I have my relative humidity. And I can go ahead and pull off all three values that I need. And so when I plug them in, I get 0.634 pound mass per minute. Then I need to find Q dot. So this is a humidification process with a Q dot. So with just a simple humidification process, this is your equation. This is your governing equation. But you don't have a Q dot. However, with this one, we do. So we've just added the Q dot, humidification plus a Q dot. And I've already figured out, well, I know what my m dot A is. It's the V dot 2 over the specific volume of the dry air at state 2. So we figured out that went out when we looked at m dot W. And then I can go ahead and pull off the specific enthalpy values of the dry air. And then if I go to my steam tables, I can get the final term in that equation, which is the H sub F at 45 degrees Celsius, or 45 degrees Fahrenheit. And that's the temperature at which I'm injecting that saturated liquid water. So if I plug it in, I get it in BTU per minute, and I can easily convert it to BTU per hour. So, all right, well, I hope that was helpful. Let me know if you have any questions.